Prince William is doing. And obviously we have the Earthshot Prize here in December. Boston, which I will be attending. I will try to get press credentials. Don't know if that'll happen. So if you haven't subscribed already, you should, because the more subscribers I have, the more requesting press credentials might be a little bit easier.
Hello everyone, good evening.
Good evening, sir.
Good evening.
Good evening, sir.
Good evening, sir.
Good evening,
Good
sir.
evening.
Good evening, sir.
Okay, so today we will be discussing only week 1 and 2. I hope you all are aware of it. So do you want to go through all those concepts again, or just want to be focused on some particular concepts and questions in these 2 weeks?
Sir, reattempt point of view, sir.
Sir, I think all of them is better.
All of them is better, but we have like 2 hours to proceed with, right? So which thing, is there any specific topic you want to majorly focus on, or
No, sir.
any specific type of questions or something which you are struggling with more in these 2 weeks?
No, sir. Not from my side.
Okay, what about others?
I have one doubt.
Yeah.
Sir, I think.
Sir, I wanted to understand continuous and discrete variable. If you could teach that.
Okay.
And classification of data. Because.
Okay.
And if we go if anyone has to understand a specific topic, they may ask you out and then you may teach. Like if we go with that flow.
Yeah, that would be better because the complete sequence of discussion, I think we already did a month back, and it might be available on YouTube also for you to refer, right? So instead of going through same, let's focus on some major topics where you guys are struggling the most. So one is discrete and continuous, okay? Okay, second was classification of data, okay. But majorly you're struggling within classification of data.
Sir, it's mainly the measurement scale.
Sir,
Yeah.
I have doubt in time series and cross section.
Okay. Scales of measurement, okay.
Sir, variables and cases identification.
Yeah, okay. So one is time series versus cross-sectional, okay.
Relative frequency, sir.
Relative frequency also, okay, we will do that. So it was cases and variable, right?
After finding the relative frequency, how to
correlation
associate.
and coefficient.
We are focusing on first 2 weeks only now. So correlation
Sir,
coefficient would be covered in next
sample
session.
and population.
Okay, sample and population. Okay, we will do that in 4th point only.
So, round of
Yeah.
errors.
Okay.
Also, point by serial correlation coefficient.
So point by serial is again week 4. We will do it in next session.
Oh, okay, all right.
Sir, category and numericals.
Pie charts, sir.
Yeah, pie chart we will cover in this round of error.
Sample and population, sir.
Okay, sample population will cover in here. Okay, any other major point?
Sir, there was this
Category numerical data.
sir, there was this question in a qualified
Just
exam. Yeah.
Okay, what's the question?
So there was this question in qualified exam that a government officer wants to evaluate the rods produced in a month. Yeah. So like when I read the question, I felt that it should be like wait a minute. मैं इसमें question निकाल लेता हूँ.
Just curious, is this being recorded?
Yeah, it will be recorded.
Thank you.
So, bimodal and multimodal data.
Okay, bimodal, multimodal. Okay, we will see that. Yeah.
It's the gold standard for the development teams. That it performed at a level that was far superior to the other teams, which tended to be a mixture of typically client developers and then some far out. So the immediate benefit was just some really good mojo with a client. Team, what if you bring your team?
We will start with discrete and continuous. No, okay. Let's do this. Okay. So before discrete continuous, are you aware of numerical and categorical? Like, are you able to identify when a variable is numerical?
Yeah.
Okay. Okay. Suppose I have, let's say, okay. Maybe two examples. Let's see. Okay. One is number of cups in an office, and second is this. Let's say, okay. Seat number of employee in office. Okay, is the first one numerical variable? Is this numerical?
Sir.
Yes.
Yes, sir. It is a numerical variable.
Why?
No, sir, it's a category.
Why it's numerical? Okay, but just states the reason along with your answer. Why are you saying it's numerical or is it categorical?
Because
It is countable and we can do addition, subtraction operations on that.
Okay, yeah. So suppose if in an office there are 2 cups and in another office there are 4 cups, we can simply add and say that there are in total 6 cups. We can perform meaningful addition, subtraction at least, right? So it is a numerical variable. What about seat number of employee in office?
It is
Categorical variable.
Numerical,
Why
sir.
categorical?
Because it is a number. So this is numerical.
No, seat number,
We
even though
cannot
it is a
perform
number,
mathematical operations on it now.
mathematical
operations on seat numbers.
Yes, a seat cannot perform any mathematical operations.
Yeah, okay.
Not
Suppose I have
compulsory
one
to
seat
perform
number
any
2.
mathematical condition.
Okay, suppose
There
we
is
have
no
two
logic
seats. One seat is
to
number
apply any
2,
method.
another seat is number 4. If I add them, I'm getting a 6. Is this a meaningful addition to perform?
No,
sir.
No.
That's right.
So that's why it's not a numerical variable, right?
Yes, sir.
Okay, so okay, we identified what's numerical and when it's not. So next part is identifying whether it's discrete or continuous, right? Add them.
So one question, sir.
Yeah.
Sir, is pin code a numeric variable?
You tell.
No, sir.
Confused, sir.
Categorical. It's
Categorical.
Yeah, on pin
No,
code,
sir,
we can
categorical.
Okay, let's say these two are
arithmetic operations.
pin codes. Can we add these two and get something meaningful?
No, sir.
No.
No, right?
Same value.
No.
Categorical, right?
Take example second.
Same goes with mobile number also.
Mobile number, okay, you think, can you add two mobile numbers and get something
No, sir.
meaningful?
It is categorical.
Categorical, right? Okay. 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 Now let's come to discrete and continuous. Okay. What values number of cups can take? Let's stick to this. What value this numerical variable can take?
I think an unlimited value.
What all are the possible values I can have for it?
It can be infinity. Like,
Yes, sir. It can be
Any
infinity.
countable number, sir.
Any countable number.
This Aswad, that's well, I think. Okay, great. Okay, yeah. So number of cups, it could be either 0, 1, 2, 3, so on, right?
Yes.
Okay. Can it take any value between 0 and 1, or would it be 0 and directly jump to 1 after that?
It has to be 0 and
cannot
directly
take
jump to
value
1.
between 0 and 1.
2, 3. Okay, let's say these are some possible value. After 0, am I directly jumping to 1, or can I take any in between values over here also?
In
Directly
between
jumping
is
to
not
1.
possible for the cup.
Not
I'm
feasible, sir.
directly jumping to 1, right?
Yeah.
Yes, sir.
Because I could either have 0 cup or 1 cup. I cannot have 0.1, 0.2 or something like that, right?
Yeah.
After 1, I'm directly jumping to 2, or can I take any in between values? Can I have 1.5 cups, 1.2 cups?
No, sir.
Directly 2.
Okay. Okay. Now let's say height of an employee. Okay. Height of an employee in office. Okay. So let me again draw. It will definitely be greater than or equal to 0, right? Starts from 0. Let's say 1, 2, and it goes on, right? Let's say something around 200 centimeter. It goes on. So here, what all possible it can take? Am I directly jumping from 0 to 1, or can I take all the values?
It can take. It
Yeah,
can take
any
between
value.
values.
All the between values also.
Possible to use these values also.
3.
And I am
Two
directly
jumping.
jumping to 2, or can I take all the values in between?
All
You
the
can take
values.
all the values.
Take, we can jump also, we can take also. Anyone.
Yeah, we can take also, right? It's possible to have all
To
these values.
Yeah.
jump 3.
Okay, so it's possible for me to, you're saying, take all the values, right?
Yes, sir. Okay, so you notice that these two variables are different in some sense, right? One is jumping from one value to another, and one is able to take all values, right?
Yes, sir.
Sorry, in a range. Okay, so whenever we are jumping from one value to other, it's discrete. Okay. And whenever we are able to take all the values in a range, it's continuous.
Decimal number.
Is
I
this
want to know,
clear? Yeah.
sir, I want to know that all the discrete values are the just numbers.
Are they just numbers? They should be numerical variable at least. Yeah.
Yeah, numerical
Should be a
value.
whole number.
No,
Whole
not
number
necessarily
Rounded
a
off
whole number.
numbers.
Not
All the
necessarily
discrete will be in a
whole
rounded off
numbers.
numbers, sir.
Any positive number.
No, sir. So it can be from 1.5 to 2.5 also. That's also a discrete value.
Yeah. Okay. Let's say I have a variable which can take possible values -1, -0.5, 0, 0.5, and 1. Is it discrete or continuous?
Discrete. Discrete.
Why discrete?
Okay.
Integers.
They have
We're
clear
jumping.
This is
spaces.
0.5.
We're jumping
If
from
there
one
is
value
no
to other.
value
We
between
cannot take
minus.
all values in
Yes.
a range, right? So it
Okay,
is
so it is continuous.
discrete, right? Is it clear? Okay, I will move to next topic in that case. Okay, yeah.
Voice is muted or
Okay. So
so
discrete,
continuous
discrete.
will be in
Yeah.
I mean continuity. There will be after one it will be 2, 3 like that.
No, no, we just discussed, right? In continuous, we
So
can take all values in a range.
voice is muted of all of our students.
Is it? No, all are able to listen me. I think you should check your network connection or something.
Hello, sir.
Yeah.
Yes, sir, you are audible clear.
Yeah.
So why negative values are discrete?
Because here also we are jumping from one value to other, right? It's not like negative values cannot be discrete. We are still jumping from one value to other. We are not taking all values in a range.
Okay, sir, but why we take 0.5?
Why would okay? Suppose you have a variable which can take only these values: -1, -0.5, 0, 0.5, and 1. Assume it's any variable you can think of which take only these values. So first value I can take is -1, right?
Yes,
After
sir.
that I am jumping directly to 0.5. I cannot take these in between values, right?
Okay, sir.
So whenever we are jumping from one value to other, it's
Okay, sir, it's discrete.
discrete, right? Yeah.
Yes, sir. Thank you.
Sir, by that mean we can say that countable elements are discrete and non-countable is continuous data.
Yeah.
This is correct.
Okay. Moving further.
Then all measurements comes under continuous, sir? All sort
All
of measurements.
Which measurements?
Any measurements like mass, weight,
Yeah.
length.
Yeah, such type of measurement would come under it. Yeah.
Okay.
Sir,
Yeah.
sir, that I was discussing about that question. So in that question, there were options about like he selected say, random 70 rods from the produced in month of June to 2022. So the question
Yeah.
was, yeah.
Yeah.
Yeah, there were options that the options were the population is all threaded rods ever produced at the factory, and the sample is threaded rod produced in the month of May 2022.
Yeah.
Then there was another option, the population is all threaded rod produced ever at the factory, and the sample is 70 selected threaded rods. And the third
Yeah.
option was the population is all threaded rod produced in the year 2022, and the sample is the threaded rods produced in the month of May 2022.
Okay.
So, sir, the question was if he selects 70 threads random produced in the month of May 2022. So, sir, May 2022 should be the population, and the 70 rods produced in that month should be sample. Like if I'm right or
No.
wrong.
Okay. Okay. So for this, we have a qualifier or quiz one discussion session. You can refer that. We have discussed this question briefly over there. We had a discussion for around 30 minutes over there. You can go and check our YouTube. Okay.
Sure. Thank you, sir.
Okay. Next thing is scales of measurement. Okay. So scales of measurement. Okay. So how many scales of measurement we have?
How many students found mute district in class?
Four.
4, right? Okay.
Sir, we are experiencing disturbance in your sound. Please be.
No, it's perfectly audible, sir.
It's a disturb
Voice is
sound of a
breaking.
student. Please mute.
Okay.
Nominal, ordinal.
Yeah. So we have nominal.
Ordinal.
Sir,
Kumar.
screen is not
For
visible here.
numerical variable, we have interval and ratio scales of measurements. Right, sir?
Yeah. Yeah. So nominal and ordinal we have for categorical. Okay, I will just label it like that. Categorical variable, we have two labels, which is nominal and ordinal. And let me just do it a bit that side, yeah. And in case of numerical variable, we have other two, which are interval and ratio, right? Okay, so you all are aware of what are categorical variables, right? These are just the labels, right?
Yes.
Yes,
Yes,
sir.
sir.
Okay, so I will give you two example of labels. Okay, so we will try to figure out what's the difference between the two. Okay, so let's say okay, source of income, right? Let's say source of income. So we might have, like, if you look at the source of income of India, we could have some from agriculture, education, and sports, let's say. And if look at another example, let's say another example be okay, qualification.
Excuse me, sir.
The
Yeah.
screen is not visible, sir.
Are you sharing a screen? Because
Is
it's
my
not
screen not
visible for
visible?
me.
It's not visible.
Okay.
It's not.
I will share again, I think, in that case.
Okay.
Okay, is it visible now?
Yeah.
Yes, sir. No, it's there.
It is visible.
Yes, sir. Visual.
Okay, so
Sir, it's clear
qualification.
from your end. It is visible, audible, and it's clear from your end, sir.
Yes, sir,
Okay,
it is visible, sir.
Sir,
okay,
your
so
screen is visible
qualification we
and
can
sound.
have class 10th, class 12th, and graduation degree, right? So both of these are just the labels, right? Both of these are categorical variables. But is there any difference between the labels which these two variables can take?
One has
Yes,
one or more.
What's the
Without or
difference?
qualification can be set in order.
Source of income is
Qualifications
nominal,
can set
sir,
be
whereas
order,
qualification is
whereas
ordinal.
nominal cannot be.
Ordinal one.
Okay, so you are saying qualification labels can be ordered, but source of income labels cannot be ordered, right?
Yes,
Because we
sir.
cannot say sports is greater than agriculture or vice versa, right? So
Yes.
whenever the labels cannot be ordered, it's nominal. Okay? And whenever labels can be ordered, it's ordinal. Okay, is it clear?
Yes.
Yes, sir.
Yes.
Yes, sir.
Yes.
Yes, sir.
Okay. Moving further, we have for numerical we have interval and ratio. Okay. Okay. I will give you
I have a question
different.
about ratio scale and interval scale.
I'm just about to cover it.
The
Okay.
ratio scale determined by
Okay. Okay. So interval and ratio. Let's. Okay. Suppose one is runs code, right? So I will. What is the minimum value of runs code in a match by
Zero.
any player?
It can be 0.
Okay, suppose in a match, player A scored 20 runs and player B scored 40 runs, right? So, distance to reach 20 for player 1, it's this much, right? And for player B, it is this much, right? Okay. Let's take another example. See what we can come up with. Okay, let's take the temperature example. So, what's the minimum value of temperature in degree Celsius?
0 degree.
Minus.
Okay,
Sorry,
so for just for your knowledge, it's minus
Minus
273.
273.
Minus 273.
Okay, and let's suppose in room A the temperature is 20
Minus
and in room
273
B the
degree.
temperature is 40. Okay, so to make the temperature 20 degree Celsius, we traveled this far, right? It went a bit. Okay, so to make it 20, we traveled this far, right? And to make it 40, we traveled this far, right? Right. So let me just write it down. Okay, I will just ask you a few questions. Can run score take negative values?
Sir?
Sir.
No.
No, sir.
No, right?
क्या कह रहे हो
Temperature?
आप?
Yeah, it can take negative.
Yes.
negative, sir.
Yes, negative.
Okay. What's the minimum value of run scored?
0.
0.
Minimum
0
value here?
0.
To minus
Minus
273.
Minus
273.
273.
Minus 273, which is not 0, right?
Which is below the 0.
Okay. Next thing is, in the first case, can you say that the run scored by player B is twice the run scored by player A?
Yes, sir.
Yes, sir.
It's like 40 runs is
No,
nothing
sir.
but 2 times 20 runs, right?
Yeah.
No, sir.
Yes, sir.
Because you can see that this pink line is a bit exactly the double the orange line, right?
Yes, sir.
In case of temperature, can I say that 40 degrees twice the
No,
20
sir.
degree?
Not
No,
at
no,
all.
No,
sir. No.
we
Not
can't.
at all.
Why not? Why?
Sir, because
The
it is in
starting
negative.
point differs, no, sir.
Yeah, because if you
Differs
see
closely.
that the length of pink line is not the double of orange line. It's right. It's not exactly the double. It's something more or less even same only, right?
Yes, sir.
So you're getting the difference, right? But so
Yes, sir.
I run scored is a ratio scale of measurement. It cannot take negative value. Minimum value is 0, and we are able to perform meaningful multiplication, right? Which is not
So
satisfied in case of
in all
temperature and degree
ratios,
Celsius.
we get the minimum value, it's 0, right?
Yeah. Okay.
So any other example of interval ratio?
Any other example? Okay, so one good example I can think of is marks in an exam. Okay, let's say you have a 5-question exam. Okay.
Okay.
On every correct answer you get +1, and on every wrong answer you lose 0.5 marks, or let's say you lose -1. Let's keep it simple. Okay, so what's the maximum marks you can score?
-5. Sorry, +5.
Plus 5.
+5. Minimum?
-5.
-5.
Okay, I think you can easily notice here that it won't be the ratio, but let's increase it up further. So suppose one student scored 2 marks, other scored 4 marks. Okay, minimum was -5. So one who scored 2 marks traveled this much, right? And one who scored 4 marks traveled this much. Are you able to say that yellow line is twice the black line? This
No,
4
sir.
marks?
No,
Yes,
sir.
sir.
No.
No, right? So
No.
it's not ratio. If I modify the exam structure now, let's say there is no negative marking. There is 5 questions. You get 1 mark for correct answer, and there is no negative marking. You won't lose any marks even for incorrect answer. But
So
is
it
the
will be
minimum marks
ratio,
in
right?
that case? Yeah,
Zero.
Zeros.
Because minimum marks we can get is 0.
yeah. Now in that case, can you say that one who scored 4 marks is exactly the twice the 2 marks?
Yeah,
Yes, sir.
absolutely.
Yes,
Yes.
yes.
So that's how you can identify between interval and ratio. Okay. Okay. So I think we have covered these two topics for now. Any doubt in these two?
No, sir. No, sir, not at all. And scale of, sir, I have doubt in scale of measurement that when there is a kilograms given, then just like
In
weights of
kilogram. Okay. What's the minimum value?
minimum value can be the any weight of any
Zero.
person.
0, right?
Yeah.
Minimum possible. Okay. Can you say 40 kg is twice the 20 kg?
No, yes, sir.
Yes, right? So it's ratio, right?
Yeah.
Hello, sir.
Yeah.
Your number on the card, which category? This is numerical or categorical?
Number on the card. Okay, you tell.
As per my is categorical, but question is saying numerical, so that's why I'm confused.
Okay. Okay.
Graded question, like
Sequence number, it can be numerical, na?
It can be numerical. Yeah. It depends on what sense you are saying. So it depends mainly on the question statement, but since you are talking about it's numerical or categorical.
that is graded assignment week 3, and that is
Week 3 and 4 we will discuss next session. Week 3 and 4 we will move on to next session. But yeah, identify numerical categorical. It's basically depends on question statement. Try to figure out using whatever we covered till now. We will discuss that in week 3 4 session. Okay, yeah. One thing to keep in mind is, yeah. So if I say in general, this thing is a numerical variable. So in some cases it might not be. Okay, you might encounter some example where you cannot generalize whether it's numerical or categorical. So it depends mainly on how data set is presented to you and how the values are given. Okay. Okay. Next thing is time series and cross-sectional data. Okay. Again, I will give you two data sets. Okay.
Sir, I have
Okay. So
doubt here in time
yeah.
series.
Yeah. Let me just cover it. Then let
Please.
me know if you still have
Go.
any. Okay.
Okay. Okay. Go.
Okay. Okay. Suppose I give you two data sets. Okay. Okay. So this is my, let's say, first data set. Okay. Here, what I am doing is, suppose I have a student, a specific student A. Right. So I'm noting down his or her marks at regular interval, like every week. So if I noted down graded assignment 1 marks, then I noted down graded assignment 2, graded assignment 3, assignment 4, quiz
Hello,
1,
sir.
GA 5, so on, right?
Hello, sir.
And we have another data set where what we are doing is, okay, so here suppose my main focus is on only graded assignment 1. I have all the students over here and their respective marks over here. What's the difference between the two data set?
So the difference between is that a student uh, on data set 1, there is you are taking a student and comparing the marks of all graded assignment, whereas in another data set you are taking a general assignment, a graded assignment 1, where there are number of students and comparing the marks of them.
So basically, in the first data set, you're just like taking a particular student and comparing
all the graded
all
marks.
his graded assignment marks. But in the second one, you're taking a particular assignment of this particular assignment of all the students and just comparing their marks.
Okay. Okay. Let me just
You're
simplify what
assessing
you
the
just
student
did.
over a period of time continuously.
Okay. So here, what we are doing is we fixed our object of study, right? We fixed it, right? And we are measuring it at regular interval of time, right?
Yes.
Okay. Here in the second data set, what we did is we are not focusing only on one thing, right? We are focusing on multiple things, right? Multiple objects at same time, right? Because grade assignment one and at the same time all of you get the score, right? Right? So if you notice in the if you notice in the first case, whenever we fixed our object to study and noted down its observation at regular interval of time, it's time series data. And when we study multiple objects at the same time, it's cross-sectional data. Is it clear?
Yes, sir.
Yes, sir.
Sir, can you repeat it, sir?
Yes,
Okay. Which part you want me to repeat?
Just the difference alone, sir. One more.
Okay. So in this first data set, what we did is we fixed our object of study, right? Like I will only focus on this one object. And what I'm doing is I'm taking observations at regular interval of time, right? For this object only.
Yes, sir.
But in the second, what I'm doing is I have multiple objects, student A, B, C, and all that, right? And I'm
Yes,
noting
sir.
down their observation at the same time, at the end of graded assignment one. At the same time, I'm noting down all their observations, right?
Yes, sir.
So in the first case where our object was fixed and we were studying at regular interval of time, it was time series. In the second case where we study multiple objects at same time, it's cross-sectional. Okay?
Yes, sir. Got it. Thank you, sir.
Sir, just a second.
Yeah.
As you have taken in student A and
Yeah.
taking graded assignment, then it
Yeah.
will be a cross-sectional.
No, I'm studying student A's performance every week.
Yeah.
Yeah. So at every week, I'm noting down his performance. How is
It
he
will be
performing in grade
cross-sectional,
assignment?
sir. It will be
No,
cross-sectional.
cross-sectional is when we study multiple objects at same time.
Okay.
Here I'm studying only one fixed object at different time periods.
Different times. Then it will be called as time series.
Yeah.
Sir, there was a question given in our assignment that Netflix is a company who has many movies. The movie released on Netflix.
Yeah.
Then, matlab there was a particular time given. Then it was asked us to identify that it is a time series or a cross-sectional.
Okay. Okay. Let me state you the question statement. The question statement was something that Netflix is noting down the number of subscribers they had at the end of some year across different
Yes.
Asian countries, right? So time period is fixed, right? End of the year 2022. And I am studying multiple
Okay.
objects which are different Asian countries, right? India, Sri
Okay.
Lanka, Bangladesh, and all that. So I'm studying multiple objects at the same time.
Then it will be time
So
series.
it will be
Cross-sectional.
cross-sectional, right, sir?
Cross-sectional. Yeah, it will be cross-sectional, right?
Sir, again, sir, can you please go through it because I am confusing in
Okay.
both the
Okay.
strategy.
Okay. So what we are studying is we are studying different Asian countries, right?
Yeah.
Okay. So we are studying about
Yes.
India, let's say Bangladesh,
Nepal.
Pakistan, Sri Lanka, Nepal. Okay. Let's say these five.
Okay.
So you are noting down Netflix subscriptions, right?
Yes.
So at the same time, what was the time period? time period was end of year 2020, right?
Yes.
End of the year 2020, what I am doing is I am studying multiple objects to get the data, right?
Okay. In a year, you are taking multiple objects.
At the end of year, the time period
And
is specifically mentioned, right? At the end of the year, so the time
year.
period is fixed.
Okay.
And I am studying multiple objects at the same time.
Okay.
So that's cross
Then
section,
it will
right?
be that cross section. Whereas if we take a particular country and
Yeah.
if we take
Suppose I fixed India only, right? And I note
yeah,
down at the end of every month, I will note down the number of subscribers they have. Then I am studying only one fixed object at different
then it is time series.
interval of time. Yeah, then it would be time series, right?
Okay, fine.
Okay.
Sir, by that
Sir,
mean we can say that.
can you show me that once again, because I want to take screenshot.
Okay, yeah, sure. This one?
Yeah. Yes, sir. Thank you.
Okay.
By that mean we can say that a cross-section data is small time and time series is.
Time series is you study same object at regular interval of time, but in cross-sectional you study multiple things at same time only. It's not something like small.
Hello, sir.
Yeah.
What is the exact meaning of regular interval of time?
Yes, sir.
Regular
This was
interval of
my question
time.
also.
Regular interval of time. Okay. So here you notice that I'm noting down every week, right? Every week I'm taking data. In subscription, I was taking every month's data, right?
Yes,
Here
sir.
we every month. So that's what it means by regular intervals of time. Every month. So we kept the interval kind of a bit same. Okay. Okay. Moving further, we have cases and variables. Okay. Cases and variables. Let's do it over here, I think.
Sir, one small doubt, sir.
Yeah.
Sir, that means in time series data, the interval should be regular interval of time.
For ideal case, we do say it should be regular, but even if it's not regular, you can say it is time
Or I
series.
can say that suppose first we have taken for quarterly, then half yearly, then yearly.
Yeah,
It
you
can
can
be a
say.
time series.
Yeah, it can be.
Okay, thank you.
But generally, we prefer regular interval to avoid misleading information.
Oh, okay, thank you.
Okay, great. Okay, now moving to cases and variable, let me just give you a common example. I think we might have done it a lot. Okay. Okay, let's just change it a bit. So let's say this is your jersey number. This is the name of player. This is runs. Okay, Mr. Beast, I need to spell.
It is not visible. Your skin is not visible.
Screen is not visible.
Yeah, one of you have interrupted in between two presentations, so I need to expel. Okay, so runs scored and next is wickets taken. Wickets taken. Okay, let's not keep it. Let's keep it average. By average here it refers batting average. Okay, let me keep it. It's number 7, 10, 15, 5. And here we keep it some player A, player B, player C, and player D. Okay. Run scored is, let's say, 1000, 600, let's say 500, let's say. 1000, let's say. Matter, let's say 60.76, 40.34, 51, so 37 point something, let's say. Okay. Okay, let me just add one more to it, keep it better. Okay, let me label it as say, country. So let's suppose they all are present in the same country. Okay. Okay, yeah, I think that would be enough. Okay. Okay, coming to this jersey number first. What all values your jersey number can take or are taking in this data set? Possible values are
10, 18, 5.
yeah, it's 5, 7, 10, and 18, right?
What number you are asking?
The possible values which jersey number
Any
can take.
number, just number.
No, in this data set, what values it are taking?
Possible numbers
7,
which?
10, 15, 5.
So your voice is breaking.
Is it for everyone or is it only for him?
No, sir, it's clear.
Clear it. Okay. So what possible values name is taking in this data set? It's
Clear A, B,
B.
A, B, and D, right?
A, B, and D. Yes.
B and D.
Runs also taking 4 different values, right?
Yes.
Average
Yes, sir.
also taking 4 different values, right? What
Yeah,
about
right.
country?
Only one value.
Only one value, sir.
Only one value. Okay. It means the value which this variable can take is constant. It's not changing.
Yeah.
But
Yes,
for
sir. Definitely.
other 4, it's changing, right? It's
Yes,
changing
sir.
and it can take multiple values. So my jersey number, let me just list it down. My jersey number, name, runs, and batting average. These are all
Yes, sir.
variables.
Yes, sir. These are all variables.
Yeah.
Because their values are varying, right?
Varying.
Country is not a variable because it's same.
It's same.
Same, right?
Sir,
Same or
just a
must be
second.
constant. Yeah.
Just a second for a point here. If the
Yeah.
country India and Australia and the other country Australia, something lies here, then
Then it would
it
be
is.
variable.
Then it will be variable. Okay.
Yeah. For now, it's not a variable because its value is not varying.
Fine, sir.
Just mute yourself, Kashish. Yeah. Okay. Next, we will come to cases. Okay. So one thing for cases is it's generally the labels of a categorical variable. Okay. So in general, we are saying it's labels of a categorical variable. So when we come to talk
Sir,
about
mobile number
cases,
is sir. Mobile
let me
number is
finish first, right?
variable. Yeah.
Okay. So these 8 values 2000, 18600,
Sir.
51, these cannot be your cases, right? Because these are not even a categorical variable labels, right?
Yes, sir.
So only
Yes, sir.
possibilities we have now is these 8 values which are highlighted, right?
Yes.
Which values can be cases?
Labels
Which
of a
can,
categorical variable.
sir, I can't understand which point you are
Okay.
saying.
Okay. So here you see runs is a numerical variable, right? Average is also a numerical
Yes, sir.
variable. So
Yes,
whatever
sir.
values, the 8 values which it is taking, 2000, 18600, 13500, 1000, 51, 37.76, these 8 values cannot be your cases now, because it should be labels of a
Yes, sir.
categorical variable only, right?
Why so,
Yeah.
sir?
It is defined like that only.
So can you repeat once again because I'm not clear with this point.
Okay, let me just finish. I think you will be clear by then. If not, we will come back. Okay.
Okay.
Okay. So now only possibilities we have for cases is only among these 8 values, right?
Yes, sir.
Okay. Another property of cases is it should uniquely identify each row.
Yes, sir. But the name is repeating, player name is repeating, right?
Okay. When I say player A, which row you are referring to?
Having jersey number 80.
We are not sure, right? It could be row 1 or row 3 also, right?
Yes, sir.
So it is not uniquely identifying each row. So I cannot have this player A, player B, and player D as cases now, right? It defeats the purpose of unique identification.
Sir,
We are
cases
only
are
left
the
with, yeah,
unique identity
of each row.
which helps us to identify the then here name is in case.
No. Here you see player A is repeating twice, right?
Yeah,
It's
yeah.
not, we are not able to uniquely identify. Like if I say player
Okay.
A, I don't know you are referring to row 1 or row 3.
Okay.
Now only option we left is jersey number. So is jersey number labels of a categorical variable? 7, 8, 10, 7, 18, 10, 5, right? These are categorical variable labels only, right?
Yes, sir.
It uniquely identify each row also, right?
Yes, sir. Yes, sir.
So these 4 jersey numbers are my
Cases.
cases because it fulfill these two properties, right? So that's how you can identify cases and
So
variables in
what if
data set.
in place of A, again, it
Hmm.
would be C.
Player C. Yeah, so in that case you can take either, whichever you prefer more.
Both will be cases, right?
Yeah, both will be.
So, sir, if we will
Sir,
take name as a case,
mobile
then
number is
jersey number would be our observation, right?
variable. Mobile number is
Can you
variable.
please go one by one?
Sir,
Both of you.
mobile number is this is yeah.
Mobile number?
Variable. Mobile number is this is yeah. Variable या कैसे? Mobile number.
Mobile number is a variable, right? Value keeps on varying depending on your data
Yes.
set.
Yes.
Here jersey number is also variable and cases are also here. But
Cases are the labels which it can take. Jersey number is a variable.
And sir, only the issue is the name in the names where player A and A are twice.
Yeah, that defeats our purpose of unique identification of rows, right?
So, and sir, for this purpose, if player A are twice, then it will not be considered as a case.
Yeah, it won't be considered as a case.
Okay, thank you.
Sir, why does runs and average doesn't come under case?
Because cases should be generally labels of a categorical variable only. Runs and average are numerical variables, right?
Sir, if it would be C,
Sir, what
then
about B and T?
names and jersey number, again, it would be, both would be cases, right? So if you will take name as a case, then jersey number would be the observation. Is it?
Cases and observations are generally the same. Cases is just another word for observations.
Cases and observation are same.
Okay.
Sir, what
Yeah.
about country?
Country is not a variable, right? Because it's taking the same value. Its value is not varying.
And sir,
It's a
it is
constant
also
value.
not a case.
Yet it is also not a case. It defeats the purpose of unique identification of
Yes.
each row. If I say India, you don't know which row we are referring.
Sir, if Australia is there in somewhere, Then it will be variable 2 and
Yeah, then
cases.
country will be variable, but it still won't uniquely identify each row, right?
But
Player B and D is case or
somewhere
not?
it will be uniquely identified, sir.
Not each row. If I suppose there is Australia in the second row, if I
Okay.
still say India, you don't know which row I'm referring
have
to,
a
1, 3, or 4, right?
question.
Okay.
Hello.
Okay.
Hello.
Yeah.
Hello.
Sir, after this BSTD complete, I can get admission in the
Your voice is breaking. I'm not able to understand clearly.
Hello.
Yeah. Voice is
complete
still breaking.
So player B and D is case or not?
No, they won't be, because it should be the labels of a same categorical variable. If player A defeats the purpose, then any other cannot be.
So as you mentioned, the player A have means there are two player A, and you given the means jersey number different. How is this? Means it can be possible.
Yeah, it is possible, right? Two players can have the
Means
same name and yet different jersey numbers.
okay.
If there is Australia only one, then it can be this case or not, sir?
Yeah. Okay, any
Hello.
doubt in this? Yeah. Yeah. Go ahead.
Sir,
20.
I have
16.
one
16.
Okay. Can you type in the chat? I'm not able to hear you properly. Your voice is breaking a lot, I think.
Please go through with other topics.
Okay, yeah. Till then, I will switch to other topic. Okay, I think we are left with only two things now. Okay.
Relative frequency and round off.
Relative frequency and rate of error. Okay. Before relative, okay. So today I will only talk about categorical variables only. So whatever concept of frequency, relative frequency we will study, it's only from the purpose of categorical variables. Okay. Okay. I will just again make up some data set and then we will proceed. Okay. So let's say you went to some car showroom, okay? And
okay.
There were, let's suppose, some 10 cars in total, and you noted down, okay, you are noting down the type of cars. Okay, so let's suppose first car was a sedan, second was again a sedan, let's say. Then you had next three were SUVs. Let's say next five were SUV. I will keep it simple. Seven. And last three you notice were hatchbacks. So this is the data set which you have noted down in the car showroom. Okay. Now, is this any easier way to represent this data set?
Using frequencies?
Yeah, using frequency tables, right? Type of car and how many cars you have is the frequency.
Sir, tally marks can also be there, no?
Yeah, from tally marks only you obtain the frequency.
Yeah, like that only.
Okay, so here we can have three possible values: sedan, SUV, and hatchback. Okay, so frequency of sedan is just 2 only, right? For SUV it's 5, and for hatchback it's 3. Okay. Okay, so from this frequency table I'm able to understand that in total I have some
10 cars.
10 cars, of which 5 are SUV, 3 are hatchback, 2 are sedan, right?
Sedans.
But I wanted to make a, let's say, report, and I'm not interested in showing them these numbers.
Frequency.
I wanted to talk about something in which gives
Unique
them a
identity.
generalized idea, right? So let's say we have relative frequency.
Okay.
Relative frequency of a label is just frequency of that label divided by total. So for sedan, it would be 2/10, which is 0.2. For SUV, it would be 0.5, and for hatchback, it would be 0.3. And it would always add up to 1. So now I can a bit say that in my data set, the
0.2.
proportion of SUV is 0.5, or there are 20% of cars are sedan, right?
Yes.
Right. So whenever you wanted to talk in relative terms with respect to all those labels you have noted down in your data set, we generally use relative frequency, right? Okay. So yeah, so that's what the relative frequency. It will always add up to 1. It will only take values in between 0 and 1 only for each label.
Sir,
Yeah.
so you told this is categorical variables. The other one is what
Yeah.
type?
It's only one variable I noted down here. It's the other variable.
Okay.
Yeah. Okay. So I think
Sir, one
yeah.
doubt here, sir.
Yeah.
Sir, also there are some questions like how can we display this categorical variable? So the pie chart and bar chart, right? So can you explain on that?
Okay, so how do we give visualization of categorical variable? That's what you're asking?
Yes, sir, exactly.
Okay, yeah. Okay, suppose, okay, so there are in general 3 ways. Okay, 3 ways to visualize. Okay, yeah. First one is bar chart.
Bar chart.
Okay,
This
second one is
pie
just a
chart.
modification of bar chart, which is Pareto chart.
Or Pareto.
And the third one is pie chart.
Pie chart.
Okay, but there is one condition on this second visualization. It only works on nominal scale of measurement. It won't work for ordinal. Okay.
Sir, which Pareto chart?
Yeah.
Sir, why so? Because it is
Yeah, we will do that. Okay. Let me
But
just
Pareto chart, we arrange it in descending order, no, sir. Then why not
descending
for
or
ordinary?
ascending. Yeah, let me just tell
both.
you. Okay, so
How
let's
does it
suppose
first
if I
frequency?
plot the bar chart, it would be sedan over here, SUV over here, and hatchback over here, right? And I would have the respective bars going. So sedan is 2, SUV is a bit, I think 5, and hatchback is in between 3, right? So that's simply the bars representing the frequency of each of these labels of categorical variable, right?
Yes.
Now, let's say you want to arrange it in ascending order. So you want to arrange it in ascending order. So I can make it
First
sedan, ascending order, not descending. Hatchback and SUV.
Okay, 2, 3, 5 sedan, hatchback,
So,
and SUV.
and then it will go, right?
SUV with the last one. Now this is the Pareto chart.
Yeah, so we have arranged it in ascending order. You can also arrange it in descending order also. Either way, it would be fine. Okay, so such type of plots are called Pareto chart. But here, if you notice that these labels, sedan, hatchback, and SUV, these are nominal, right? We cannot order these labels. So generally, you can shuffle them. Okay, but suppose you have some labels which can be ordered. Let's say it's bad, average, and good. These are the labels of a categorical variable, and it can be ordered, right? So it's ordinal, right? So let's suppose your frequency is
Sir,
for
here,
something like this.
excuse me.
Yeah.
Sir, here how can we order, because there is not a range, because say sedan, SUV come first, then sedan, then hatchback, like that. So
That's nominal, right? We cannot say that SUV is greater than hatchback or hatchback is greater than sedan, something like that. We cannot say that, right?
so how can you say that it is a categorical?
It is nominal.
Nominal, how do you install?
Okay, why are you saying it's ordinal? Tell me that first. We just
Hello.
studied scales of measurement, right?
On the basis judgment of.
What's your judgment? Like, what's the point you are, like, what should it be? If it's not nominal, what it should be and why? Give your point first.
Sir, nominal is because just it is a names of cars, sedan,
Yeah,
hatchback, and SUVs.
yeah,
These
that's
are
what
the
I'm
name of
saying.
the
It is
cars.
nominal.
That's why it is nominal.
Yeah,
And
we cannot order
if
it,
a
right?
category, okay, fine, fine.
But here I can order it, right? Bad is definitely less than average, average is less than good.
Okay.
Now, if you want to arrange them in ascending order, then it would be something like this, and it would be bad, good, and average, right?
Average,
So here
like
you
that is
say
a
that here your order gets violated. Now this order is no longer followed, right?
Got it, sir.
So that's why for Pareto chart we generally use it only for nominal. Scale of measurements, not.
Sir, it violates the chart on when it is not in like order, just a bad, average, and good. And
Yeah,
in
it should
if
be in
we
the same order. Yeah, it should
yeah,
maintain the order over there. Okay. Okay. Moving further, we
the
have
Pareto
this.
categorical or ordinal type of data.
Yeah, in ordinal we avoid Pareto chart. Okay, let's see about your pie chart. So here we have, I think, some 20% goes to, okay, this 50% goes to your SUV, 20 goes to your sedan, and 30 goes to hatchback, right? Because that's what we figured out, right? It's 0.5 means 50%, it's 0.2 means 20%, it's 0.3 means 30%, right? Now, let's say your data set is a bit modified. You don't always get these perfect numbers, right? So let's say your your SUV was 26.76. Okay. So let's say sedan is 26.76. 50%, let's say it's SUV. It's simple.
And the rest of the
And
is hatchback.
remaining 23.24, we will keep it.
Yeah.
Okay. Now again, we are saying to do the same plotting. Let's say again the 50% goes to SUV, right? And some 26.76 goes to sedan, and remaining goes to. Okay, I think I have interchanged it, but that's fine. Okay, now you suppose mentioning the proportion or percentage it has in your data set. So here it would be 50%, right? Here you rounded off to 27%, and here you rounded it off to 24%. So what happened is your total joint percent becomes 50 plus 27 plus 24, which is
101.
101%. It becomes greater than 100, right?
Right. Yes, sir.
Which should not be possible, right?
Sir, so what we can do?
That is rounded off error.
Yeah, that's round off error. We got this error because we rounded off 23 point something to 24 and 26 point something to 27, right? So that's what we refer to as round off error in pie chart.
Errors. Okay. Sir, instead of rounding error, rounding of the numbers, we can simply write in decimal so that
Yeah,
it would become 100.
yeah, that's what
Complete.
you need to take care of. Yeah, that it should be add up to 100.
Okay.
Okay, I think we have covered all the 6 topics. Okay, any other thing you want me to cover in these 2 weeks?
Sir,
Here
for the
is one
bar
of
chart
the
thing,
more
can you
topic.
explain it once again?
One of the more topic is here.
Sir, can you just
Just a second, please.
repeat this
Guys,
last topic, round of error? The
Okay,
example.
okay, so see, the actual percentage for sedan was 26.76, right? But you rounded
So,
off to 27%. Okay.
yes.
For SUV it is 50. For hatchback it was 23.24, but you rounded it off to 24% just to keep it simple.
Okay.
Right? So what
Yeah.
happens is when you add up all these percentages, you are getting something greater than 100.
Yeah.
Which is not possible in real life, right? It should definitely
Yeah.
all
Yes.
should add up to 100. But you are getting
Yes.
something greater than 100. Why? Because you rounded it off.
Mm-hmm.
That's what we call it round of error. We are getting.
Okay. Clear. Thank
Bar
you, sir.
chart, can you explain again?
Excuse me, sir.
Yeah.
Actually, Pareto's chart is we see it is always in order, no, sir.
Yeah, it's always in either ascending order or descending
Ascending
order.
or descending. But you said that we have to take nominal.
Yeah, because when it's ordinal, what happens is this order of this gets violated. Actual order is bad, average,
After
and good,
using
right?
the Pareto chart, we'll get
Yeah, the order gets violated, right? Bad, good, average. So that should not happen. So Pareto chart, we keep it only for nominal.
Okay, thank you, sir.
Suppose if the ordinal chart is there, right?
Okay.
So that is the ascending order, descending order that comes under Pareto chart.
Yeah, if your categories are not getting violated, it's fine. But if it gets violated after engineering to ascending or descending order in terms of frequency, you should avoid it.
Yeah, okay, sir.
Sir, today this is all last topic. So,
You want any other? You have any doubts? Other doubts in week 1, 2? We can take up.
Sir, I have one question, sir.
Can you discuss the central
Hello, sir.
tendency?
Yeah.
Hello. Sir, can you discuss the central tendency? That means.
We will discuss it in next session. It's week 3, 4.
Okay.
Sir,
What is area
Yes, sir.
principle in bar chart?
assignment.
चुप हो जाओ भाई, क्या हो गया?
Descriptive statistics.
One by one, please. Yeah.
Differential and inferential.
Repeat time
Descriptive and
series
inferential
and
statistics.
cross-sectional
Okay, I'm
population.
not able to hear
Too
anyone.
many
Can you all just
Hello.
raise your hand and speak only when I call your name? Okay. Just raise your hand if you have any doubt. Okay. Yes, Shrikant. Shrikant Naidu, do you have any doubt? Here. Okay. Next is Vineet. You have any doubt?
Yes, sir. I have doubt in time
Yeah.
series and cross-sectional. Sir,
Time
if the
series,
data is
cross-sectional.
yes, sir.
Okay.
Hello.
Yeah.
If the data is collected in January or February, after that continuously March, April, we collect the data. So it's a cross-sectional or time series.
What should it be for you?
If weight of a man means he measures in January but not February, after that he measures all the.
Yeah, so see what's happening is my main focus is only on one object, which is weight of one specific person, right? And I'm noting down that observation at different time periods, right?
Yes, sir.
That is time series data.
But he not measures now February.
Yeah, it doesn't matter. It's still after January you are going to March, right? And still measuring it. You are
Okay.
measuring it at different time periods still, right?
Okay.
Okay.
Can I come to the Petro chart once again?
Yeah, sure. Okay. What's the issue in Pareto
So
chart?
you are showing us the nominal Petro chart, but when you're presenting, you should be ordinal only, no?
No. Pareto chart is drawable only for nominal scale of measurement. It is not drawable for ordinal scale of measurement.
Okay. Understand. Thank you.
Okay.
So there's one more. The
Yeah.
beginning we given that
Okay, I will come.
What is the area principle in
Harun,
bar
you have
chart?
any doubt? Harold, you have any doubt? You raise your hand.
Sir,
Yeah.
what will be the weightage of the mark for the first 2 weeks in the exams? Questions? How many questions we
That
should expect?
thing I can tell you by next sessions. For now, I can't tell.
Okay, right.
Okay, Zainab, you have any doubt? Zainab Fatima.
Yes, sir. Descriptive and inferential statistics.
Descriptive and inferential. Okay, I will add it to list now. Okay. Okay, so descriptive and inferential we want to discuss. Okay. Okay. Yeah. Okay. We'll come to it. Let's move further. Okay. Next is Lakshita. You have any doubt?
Yes, sir. Discrete and continuous. Can you explain once?
Discrete and continuous. Okay. Have you joined late or you joined?
Yes, sir. I was joined late. That's why.
Okay. So you can go back on YouTube and check it.
Do we have this session recorded?
I think so. Yeah. I think so. It's recorded.
Yes, sir.
Yeah, sir. It will be
It is live
available
on
in
YouTube.
It will be available.
It is available on YouTube live.
Next thing is Pranjali. You have any doubt? Pranjali Vesa.
Yes, sir.
Yeah.
Yes, sir. So if we, pie chart add up to 100, then it's not a round of error, no?
Yeah, then it's not round of error. Even
Okay, sir.
it's possible you did some round off and still gets it add up to 100. It's not round of error.
Okay, so I have another doubt. Can we say all bar charts are a Pareto charts?
No, all bar charts are not Pareto chart because if you look at this chart, this is bar chart, right? But it's not
Yes, sir.
Pareto chart because we haven't arranged it in ascending or descending order. But the reverse is true. All Pareto charts are bar chart.
Okay, sir.
So Pareto charts are always either in descending order or in ascending order, right?
Yeah, right. Okay. Okay. Further, Manju, you have any doubt?
Yes, sir. Where can we find more problems to work on, sir? Apart from graded assignment and practice assignments.
Practice assignment, first practice assignment, like practice assignment 1.1, 2.1. Every time you refresh, you get a new set of 5 questions to practice on.
Oh, okay, sir. Okay, I'll try that, sir. Thank you.
Okay, next is Manish. You have any doubt?
Yes, sir. I have a doubt in my practice assignment 2.2, sir.
Okay.
The first question, sir. And the 18th question.
Practice assignment 2.2. Okay. Okay. First question and the 18th question you are saying, right?
Yes, sir.
Okay. How did you approach the first question?
Sir, I have wait, sir, I'll just open that. Yes, sir. I have just made a table where first coach, second AC, and third AC was written. And next, I made a table where the limit has been given. That is, first AC has one coach, and second AC has 5, and third AC has 9 coaches.
Okay.
And the maximum capacity of that berth. And next table I have made on that every berth has to, on a particular day I have made a table of first AC berth of 10th, second of half of 2A, half of the berth means it's 24, and third AC is like 270.
Okay, why it's 24 and not 120?
Sir, because they asked half of that 2A birds.
Yeah, so how many 2A birds we have in total?
Sir, we have 2A birds like 48 into 3.
48 into
Is
5, right?
240, sir. Half is 120.
48
Yeah.
into 2. Yes, sir.
48 into 5, right? We have 5 2A birds. Each
18.
Yes, sir.
5 2A classes we have, and each class have 48 birds. So in total we have 240 birds, right?
Yes,
Of
sir.
which half are filled, which is 120.
Yes, sir.
Okay, so I think that's the mistake you are making. Similarly,
I was making
180
mistake on 275, sir.
Yeah. So similarly, 1A class we have only one 1A class, right? So in total we have 18 births, 120 births in 2A classes, and we have 9 classes of 3A. So in total you will have 9 times 64 births in 3A, right? 64
Okay,
births in each of the 3A, and you have in total 9 3A coaches, right? I think that's where you
sir.
made the mistake.
Okay, sir.
Okay, but about question number 18, find the number of objects of type B that is in drilling stage. Drilling stages. Okay, so type B you had in total 200 objects, right?
Yes, sir.
Of which 0.25 are in drilling stage. Which is 0.25 of 200? Okay, how did you obtain 0.25? This is the relative frequency, right?
sir.
Yes, sir.
0.25 is frequency upon total frequency, right? Total frequency, you know, it's 200 for type B. So you can
Yes, sir.
obtain frequency now, right?
200. Sir, can you repeat it once again, sir?
Okay, how you find relative frequency?
Sir, total by some number of total, then sum of number of.
So, okay, so
Frequency by total, sir.
Given
for,
frequency.
for drilling stage, we don't know frequency, right? But we know total frequency is 200 of type B, right?
Type B, yes, sir.
We also know relative frequency of drilling stage. So frequency upon 200 should be equals to 0.25, right?
0.2. Yes, sir.
Now can you find the value of frequency for drilling stage?
Yes, sir.
Right? So that's, I think, question number 18. Similarly, 19 you can do.
Yes, sir. 19th I have.
Okay. Your next is Mohammed Shoaib. You have any doubt?
Yes, so as you means cleared out about the round of errand, what are the other misleading graphs like violating area principle or about the truncated graphs?
Yeah, there are a lot of it. You can refer the lecture if you want to know all of them. You are struggling with some specific of it.
Mm-hmm.
If you want to know all, just go through the Usha ma'am's lecture again. I think you will get an idea of it.
Just about little about the area principle.
Area principle, okay. Area principle you can do.
Can I support me that this where practice 2.1, the Jersey numbers? Good question.
Okay. Okay. Let's say this is. We'll just keep it a bit short data set for you to understand. Okay. Let's say this is category A. This is category B. Okay.
Yeah. Okay.
We generally try to keep the width same.
Mm-hmm.
Okay. So what it means is, it means that its value is 2, its values is 3. Let's say it's 1 unit only. So how we say it's 2? It's generally the area. 1 into 2 equals 2. 1 into 3 equals 3.
3.
But now you wanted to show that A is bigger than B.
Mm.
Using this. So what you can do is, 0 over here, 1, 2. So your A goes here, right? That's 1 unit. And its height is 2. So its area would be 1 into 2 equals 2 only, right?
2. Yeah.
But for B, what you can do is you can keep it till 1 and expand it to 3 units.
Up to 3 units. Okay.
So its area is now 1 into 3, which is 3.
3.
So you are showing the correct data, but you are violating the area principle. You are not keeping it
Yes.
the same way. That's how you can do it.
Okay. Thank you, sir.
Okay, moving further. Next is Harsh Kapil. You have any doubt?
Also same cleared.
Okay, great. Next, Silver. Do you have any doubt? So next is Vineet Pandey. You have any doubt? Okay, I think that's all. Okay, so one thing which we got new for discussion is descriptive and inferential statistics, right?
Yes, sir.
Okay, so let's discuss. Okay. Okay. Okay, so just a quick question. Okay. Okay, so how many students would have appeared in class 12 board exam this year? Any idea?
What's up?
How many students have appeared in class 12 CBSE board examination? Any idea?
3 to 4 lakhs.
3 to 4 lakhs. Okay. 3 to 4 lakhs. Okay. So suppose you are interested in knowing their mathematics marks. Would it be feasible for you to go and collect the data of all these 4 lakh students?
No, sir.
No.
No, right? So, but what we can do is we can definitely collect for a few, right? We can definitely collect for 100, 200 students. It's feasible for us, right?
Yeah, from different states or different countries.
So let's say this is student name or roll number, and this is their marks. Okay, so I have this, right? So this is my collected data, right? This is my collected data. So in my collected data, I can describe my collected data, right? That its minimum marks is, and this is 23, maximum is 100, average marks is 57. I can describe my collected data, right?
Yes, sir.
So that's what we call as descriptive statistics. We are describing the collective data. Okay. But my major focus is to know about these 3-4 lakh students, right? So using my collected data, I can make some prediction about my 3-4 lakh students, right? My major population I'm interested in.
Yes,
Can make
sir.
some prediction or draw some inference, right? So that's what we call inferential statistics. That's the difference between the two. So whenever you describe the collected data, it's descriptive statistics. And whenever you use the collected data to make some prediction or draw inference about your population data sets, it's inferential statistics.
Okay, sir.
Clear?
Yes, sir.
I will just mark it as done in that case. Okay. Any other thing, anyone? Shall we wrap up for today?
So structured and unstructured data.
Structured and unstructured data. Okay. What's your understanding of the two? What's your understanding of the structured and unstructured data? Okay, who was asking this question? Please give your thoughts so we can begin.
Sir,
Yeah.
sure.
Sorted data is a
Structured
structured
data
data.
will be tabular.
Let me just add one last point. It's structured versus unstructured data set. Okay. Okay. Give me a minute. I might have some good data set to show you.
So,
Yeah.
can we predict only collected data or whole data?
Can we predict?
Collected data only or whole data?
Using the collected data, you can make prediction about your population data set, right?
Yes, sir.
So we take, whenever it's not possible for us to get the complete population data, we take some samples and then use inferential statistics to predict them.
Okay, sir.
Okay. Okay. For structured data, let me show you one sample data set. Okay. So are you able to understand properly anything from this data set? It's just some random text written by, separated by commas, right?
We have to
Yes, sir.
clean this data set.
Right. So such kind of data set which are not organized in a well-structured tabular format, we say such type of data are generally text-heavy formats. It's generally random text separated by commas. This data set is your unstructured data set. Okay.
Okay.
Now, what would be structured data set now? Okay, let's see. This is it. Okay, so if you have noted carefully, there was some company name over there in this data set. Then if there was R&D spend they have done, then some admin spend they have done, and so on. So now I can organize, this is company name A, B, C, this is some amount spent, this is some amount spent. I have written down this data set in a well organized structured form. Now it is easy to read and able to understand, right? That company
Okay.
A has did some expenditure on R&D, they did some, like they invested some in admin sector and all that, right? So
Yes.
now this is in a well-structured tabular format and we call it a structured data set. While the previous data set which I showed you is a just text-heavy comma separated numbers written. So that was example of unstructured data set.
Okay.
Is it clear?
So if there is means we have a bill of a shopping mall, and in that we have a means a column of suggestion. In that we have write anything
Yeah.
sentence or so that what is that? It is
That
means
would be
uh,
again something very text-heavy, right?
yeah.
So text-heavy thing which is not organized in a well-structured format, it's unstructured, right?
Yes. Okay. Thank you. Means which is in the form of organized way in a manner
Yeah, that would be
that is a
structured.
structure.
Yeah.
Okay. Thank you.
Okay, I think that's all for today, or anything else anyway? Okay, we will.
Stem and
Yeah.
leaf.
Yes,
This
yes. Human leaf
Stem and
time.
leaf we will cover in week 3 and 4, right?
Okay, sir.
Okay, guys, I think that's it for today. Thank you, everyone. Good night.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir. Good night.
Thank you so
Good
much,
night.
sir.
Thank you,
you,
sir. Good
sir.
night, sir.
Thank you so much.
Thank you so much, sir.
Thank you, 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 sir.